In this video, I show you how to cut, connect, crimp, and ultimately insulate the glycol drops from your header down to your tanks so they can look like this. This step in the process is one of the most enjoyable parts to do if you are building out a brewery or a beverage manufacturing facility, because it's the first real progress to where you're connecting tanks and getting things to start working. So this is a project that I've been working on just outside of Austin, Texas for several months. We poured the slab, coated the slab, and placed all of the equipment on the slab and started making electrical connections and wiring, and now we are going to make these jumpers that will feed glycol to the tank. Now, the general rule of thumb here is you want to have the glycol pump into the bottom of the glycol jacket and come out of the top port of the glycol jacket. To begin with, we make a manifold for the bottom inlet of the jacket that has a solenoid valve and a manual valve for isolation, and on the top jacket there is a single connection that feeds to an elbow, which we'll show in just a minute. So we're using 1-inch PEX on this job site, and this is a coil of it. It's quite unruly, so you have to kind of roll it out and use force to straighten out the pieces, measure them, and then cut them for the long drops from the glycol header down to the tanks. And I didn't get a lot of this on camera, so there you go. And to cut PEX, you need this ratcheting PEX cutting tool. So you just measure the lengths to the specific sections that you need to cut and clamp down, and it should make a nice, straight, clean cut. Once you have the pieces cut, you can start to stage them together with the other components. This is an elbow piece that we're going to slide this little 3-inch piece into. And in order to crimp these down, we use this Milwaukee crimping press. This tool has replaceable heads so that you can choose what size you're crimping. This is a 1-inch Viega crimping head, and it will get around these 1-inch fittings. So you can open that clamp and press this button, and it will crimp the metal sheathing around that PEX tubing. You want to push the PEX all the way in to where you see white in the hole in that little metal sheath. Put the crimper tool around it, engage the crimping device, and it will put pressure on that area and crimp it down to make a watertight seal. And it looks like this one got crimped pretty good. And I have superhuman strength, and even I can't get this off, so looks like we did a good job. It's always good to stage these parts before you crimp all of them together, so I'm putting this piece that we just crimped in here, making sure that that PEX is all the way in, and connecting the longer drop PEX tubing to this to make sure that it fits appropriately. Before we get everything nice and crimped down, we want to put on our long lengths of insulation. This is a closed cell rubber insulation called Armaflex. It's very squishy and nice. It's about a 3/4 inch wall right here. Super important to glycol runs, but it happens to be the most expensive part of this whole project as far as the glycol is concerned. But we want to slide these lengths on to the long drops from the glycol header before we get everything crimped down. And once you have the insulation on the drops, you can then connect the long drop to the staged components down on this manifold and crimp them so that they're nice and secure. And again, this is the permanent final crimping, so make sure that all of the connections are connected and crimped properly, because I have made that mistake before and glycol comes spewing out. And right here, you do some more technical insulating. This requires a little bit more skill, but you're basically going to cut this insulation to fit together over the manifold pieces. You can see that I've cut a 45-degree on this small section of insulation that will meet up with another 45-degree piece that goes over the rest of this manifold. You then need to cut it lengthwise and cut out little sections for the solenoid head to protrude and the valve handle to protrude. Once all the insulation pieces are fitted on, you can use this really awesome insulation tape that's obviously sticky on one side and insulation material throughout. You use it to cover the vertical or lengthwise cuts in the insulation first, and then you can come around and do the insulation circumference around the joining areas so that it's nice and covered up and looks pretty. This is the part of the process that makes everything kind of come together and look really nice. It also serves a functional purpose in that it covers up these exposed areas so that you don't get a lot of heat loss, which can surprisingly affect the cooling capacity of the whole glycol system. So yeah, this part's kind of technical. This is what takes the longest in the whole insulating process. And again, all of this insulation is the most expensive part of making these glycol drops, which is pretty surprising, but it's definitely necessary so that you don't have a lot of heat loss in your glycol system. And there we go. We have 2 drops to 1 tank out of 6 tanks completed. And for some clarity, in order to make these drops, we use this George Fisher valve from these headers to make a MPT to crimper connection so that those drops can go all the way down to the tank. And this is what it looks like when it's done. So the insulation and the connection work was probably a full day of work, probably was there 8 hours, but knocked it all out. It was pretty nice to see this done, and it makes the brewery look a whole lot better. Not to mention this brewery is now functional, or at least the tanks are functional. They have glycol lines run to them, and we can now fire up the glycol chiller, run glycol through these nicely insulated lines, and control the temperature of all of our fermentation vessels. Thanks for checking this out, and I hope this helps you make glycol drops in your brewery.